August 25, 1944. Highway N13, northern France. German officers from the 21st Panzer Division stood beside the road, their Wehrmacht uniforms dusty and torn, waiting for American transport trucks. They had surrendered 2 days earlier after their fuel ran out 30 kilometers from the front lines. Not destroyed by superior firepower, not outmaneuvered by brilliant tactics. Simply stopped because their supply wagons, pulled by exhausted horses, could not keep pace with their retreat. What these officers witnessed in the next minutes would challenge every assumption they held about modern warfare. An American convoy appeared on the horizon. Not a dozen trucks, not 50. Over 200 GMC vehicles stretched in an unbroken line, each one loaded with supplies, moving at 40 miles per hour. Every truck identical, every load standardized, every driver maintaining precise 60-yard spacing. The convoy passed without slowing, a river of quota, mechanized efficiency that continued for 11 minutes straight. These German logistics officers understood supply lines, transportation networks, distribution systems, but nothing in their training had prepared them for this scale and speed. The Americans were moving more supplies in a single convoy than an entire German Panzer Division could transport in a week. They did not know that this convoy was part of the Red Ball Express, a truck network operating 5,900 vehicles carrying 12,500 tons of supplies daily. They could not comprehend that this was merely one route among dozens, and they had absolutely no concept of the mechanical revolution happening in American supply depots that made this impossible flow of material sustainable. The forklift. A machine so simple that German military planners had largely ignored it. A tool so effective that it had transformed American logistics into a weapon more decisive than any tank or bomber. These officers were about to discover that America had not just outproduced Germany. It had fundamentally reimagined how war was supplied. The mathematics of defeat were already written, though few German officers recognized them. The German military relied on manual labor for over 90% of its cargo handling operations. American forces had mechanized approximately 75% of similar tasks. A German supply depot required 140 men to unload and sort cargo from 10 trucks in 8 hours. An American depot with forklifts and 24 men accomplished the same task in 90 minutes. This disparity extended across every level of logistics operations. The transformation had begun in 1941, when the Office of the Quartermaster General recognized that war would create labor shortages that manual handling could not overcome. Representatives toured civilian factories using mechanized material handling equipment. They observed that forklift trucks and pallets, combined with standardized loading procedures, increased efficiency by factors of 5 to 10 compared to manual methods. The recommendation was immediate: mechanize military logistics completely. Congress allocated funds in September 1941 for large-scale forklift procurement. Then came the first obstacle. American forklift manufacturing capacity was wholly inadequate. Only 25,000 forklifts existed in the entire United States when war began, mostly in civilian industry. The military needed thousands more within months. Several industrial plants were hastily converted to forklift production. The Clark Material Handling Company, which had developed early forklift models in the 1920s, rapidly expanded production. By 1942, Clark was manufacturing 2,000 forklifts monthly, compared to 50 to 75 before the war. Throughout World War II, Clark supplied 90% of all forklifts used by American military forces. But machines alone solved nothing without a revolutionary change in how supplies were packaged, stored, and moved. Enter the pallet. Before 1940, pallets existed but were not standardized. Hundreds of different sizes circulated through American industry. Military depots receiving supplies discovered that incoming pallets often could not be reused for outbound shipping. Forklifts designed for one size could not handle another. The inefficiency was staggering. In 1942, military logistics commanders ordered immediate standardization. The Navy adopted the 48 by 48-inch pallet for ordnance. The Army followed the same standard. The Quartermaster Corps selected 32 by 40 inches for most supplies, recognizing it would serve 85% of requirements. By 1944, only 3 sizes remained authorized: 32 by 40, 36 by 48, and 48 by 60 inches. This standardization created something unprecedented in military history: a completely interchangeable supply system. A pallet loaded in California could be handled by any forklift in any depot in England, France, or Germany. Reuse rates skyrocketed, loading times plummeted, and the German military, still moving supplies in wooden crates loaded by hand onto horse-drawn wagons, found itself competing against an industrial system it could not match. The impact became visible in every theatre of war, but nowhere more dramatically than in the European campaign after D-Day. When Allied forces landed in Normandy on June 6, 1944, the temporary port facilities known as Mulberry Harbours had to process incredible volumes of cargo. By the end of June, they had unloaded 170,000 vehicles, 7.5 million gallons of fuel, and 500,000 tons of supplies. German logistics officers studying Allied operations were baffled by the speed. Intelligence reports noted that American depots unloaded cargo ships in a third of the time German ports required. The secret was not more workers, it was forklifts and pallets. A typical American supply ship carried cargo preloaded on standardized pallets. Forklifts moved these pallets from hold to deck. Cranes lifted them to the pier. More forklifts moved them to sorting areas. Additional forklifts loaded them onto trucks. One pallet might be handled by 6 different forklifts in 6 locations, but it was never manually unloaded and reloaded. The contents remained secured from factory to front line. German ships, by contrast, required manual unloading of individual crates. Dock workers hand-carried items or used simple hand trucks. Each transfer point meant another round of manual loading and unloading. The time difference was dramatic. The error rate was significant. The manpower requirement was unsustainable. September 1944 brought thousands of German prisoners to staging areas before their transport to America. Here, captured German officers witnessed their first close view of American logistics in operation. Ports like Cherbourg processed supplies 24 hours daily. Under floodlights that turned night into day, German prisoners watched small vehicles with vertical masts moving palletized cargo with impossible ease. Each machine, operated by a single soldier, lifted loads of 3,000 pounds to heights of 12 feet. The machines moved smoothly, quickly, precisely. Intelligence reports had mentioned American mechanization, but reports conveyed statistics, not reality. Seeing a single American soldier, seated comfortably in a forklift, accomplish work that would require 12 German soldiers with hand trucks was psychologically devastating. Officers who had studied logistics at German military academies watched American operations with growing comprehension. What they were witnessing was not just technological superiority, it was a fundamentally different philosophy. The Germans had designed their supply systems around available manpower. The Americans had designed their systems to minimize manpower requirements. German logistics depended on skilled individuals. American logistics depended on efficient systems. The implications were profound. The journey to America reinforced these lessons. Liberty ships carrying prisoners had been built at rates German officers considered physically impossible. The ships themselves demonstrated systematic organization that seemed almost obsessive to German military minds. Every pipe was color-coded, every valve was labeled, every system had redundant backups. This was not how German military equipment was designed. German engineering emphasized craftsmanship and performance. American engineering emphasized standardization and mass production. The Germans built superior individual machines. The Americans built superior systems. Upon arrival at American ports, prisoners were processed through logistics systems that demonstrated American efficiency at every level. Supply operations issued uniforms, blankets, toiletries, and personal items in assembly line processes. Each prisoner received identical items. Nothing was negotiated or customized. Everything was pre-packaged, pre-portioned, predetermined. The supplies came from depots where forklifts had loaded them onto pallets, where other forklifts had moved them to transport trucks, where still more forklifts had unloaded them into distribution areas. Not one item had been manually carried more than a few feet. Prison camps, built to house German and Italian prisoners, were monuments to American construction capacity. Facilities like Camp Shelby in Mississippi had been built in 4 months. They housed thousands of prisoners in wooden barracks with electric lights, running water, flush toilets, and steam heat. Camp supply warehouses were larger than many German factories, and they operated with small staffs using forklifts. By November 1944, labor shortages in American agriculture led to prisoner labor programs. German prisoners were trucked to work sites across the United States. This decision, driven by necessity, gave these men direct exposure to American logistics at the ground level. At warehouses and distribution centers, prisoners witnessed operations that defied their understanding of supply logistics. At a cotton warehouse in Mississippi, prisoners assigned to loading operations expected to carry bales manually, as would have been standard practice in Germany. Instead, they watched as bales were stacked on pallets by machinery. A forklift moved multiple pallets at once to loading docks. Another forklift loaded them directly into rail cars. The entire operation required 3 men plus prisoners who simply guided pallets into place. 20-man work details spent more time waiting than actually working. The psychological impact of this efficiency was profound. German logistics officers who had supervised supply operations for divisions with thousands of men watched 3 American workers with 2 forklifts accomplish work that would have required dozens of German soldiers working full shifts. The ratios were almost incomprehensible. What took German supply battalions entire days, these Americans completed in hours. And the American workers did not look exhausted. They looked bored. One German officer who had managed logistics for an infantry division made calculations in a notebook. In his previous role, loading 40 trucks with supplies required 160 man-hours of work. 8 men per truck, 2 hours per truck. Here in America, he watched forklift operators load the same quantity in 4 hours total. The American system used 96% less labor to achieve the same result. The mathematics were inescapable. This was not a marginal improvement. This was a fundamental transformation of what was possible in military logistics. At ammunition depots, the efficiency was even more striking. German officers watched Americans use forklifts to stack artillery shells on special pallets designed for the purpose. Each pallet held 12 shells weighing approximately 900 kilograms total. A single forklift operator could retrieve a pallet from storage, transport it to a loading area, and place it in a truck bed in less than 3 minutes. The same operation performed manually would require 4 men working 15 minutes. One American with a forklift did the work of 20 German soldiers in the same time period. The scale of American operations was equally impressive. At quartermaster depots, warehouses were larger than any facilities most German officers had seen. Some covered 5 or 6 acres under a single roof. Multiple forklifts operated continuously in organized patterns. Each forklift moved approximately 30 pallets per hour during regular operations. Each pallet held 1,000 kilograms of supplies on average. The mathematics were simple but staggering. 5 forklifts could move 150 tons per hour. A comparable German depot would require 200 men to achieve half this throughput rate. German engineering officers were particularly struck by how Americans had mechanized everything possible. Electric pallet jacks moved loads short distances within warehouses. Conveyor systems transported canned goods and packaged items between sections. Specialized forklifts with extended masts stacked pallets 3 and 4 levels high. Nothing was carried by hand if a machine could do it. This was not laziness. This was engineering efficiency applied systematically to every operation. These observations were consistent across prisoner camps throughout the United States. German officers sent to facilities in Georgia, Texas, Arkansas, Louisiana, California, and other states all recorded similar impressions. American supply depots achieved impossible efficiency through 3 key elements: mechanization, standardization, and systematic organization. Every depot followed the same principles. Every operation used the same equipment. Every procedure was documented in manuals that any trained soldier could follow. Engineering officers assigned to work at railroad yards watched as Americans unloaded freight trains faster than Germans could imagine. Forklifts drove directly into boxcars. They removed palletized cargo and transported it to warehouses in continuous motion. A 40-car train was emptied in 4 hours. In Germany, similar trains required 2 full days to unload using manual labor. The difference was not work ethic. German workers were not lazy. The difference was mechanization. Americans had tools. Germans had only muscle. At food distribution warehouses serving military installations, German prisoners encountered operations at scales that defied comprehension. One facility in Louisiana covered 8 acres under a single roof. The warehouse operated continuously in 3 shifts, providing supplies to installations across the southern United States. Automated conveyor systems moved canned goods from receiving docks to storage areas without human handling. Forklifts stacked pallets in aisles that stretched hundreds of feet, organized in grids that allowed precise inventory tracking. Electric vehicles carried supervisors through the facility to inspect operations. Refrigerated sections maintained precise temperatures for perishable goods using industrial cooling systems. The facility processed extraordinary volumes. On average days, 200 trucks arrived with supplies. 200 trucks departed with orders for military installations. Each truck was unloaded in 15 minutes using forklifts. Each truck was loaded in similar time. The warehouse moved 4,000 tons of food supplies daily. To put this in perspective, this single facility distributed more food in 1 week than many medium-sized German cities received in a month during the war's final year. American supervisors, often civilians with pre-war experience in commercial logistics, explained their systems to prisoner work crews through interpreters. One supervisor, a former grocery distribution manager, walked German prisoners through the operation. He explained that everything was standardized according to military specifications. Can sizes followed established dimensions. Boxes were built to hold specific quantities. Pallets were constructed to exact measurements. Trucks were designed to carry calculated loads. When everything is standardized, everything becomes predictable. When everything is predictable, everything can be optimized. The supervisor demonstrated the principle. He showed how cans of vegetables were packed 12 to a box. 40 boxes fit on a standard pallet, 20 pallets fit on a standard truck. If a military installation needed 480 boxes, the warehouse knew immediately that this was 12 pallets requiring 1 truck with space remaining for 8 additional pallets. The mathematics were simple because the units were standard. There was no estimation. There was no guessing. There was only calculation. German officers found this approach revolutionary. In German military supply operations, estimation was standard practice. Officers with experience judged by eye how much cargo would fit in vehicles. Sometimes they loaded too much and had to unload portions of shipments. Sometimes they loaded too little and wasted transport capacity. Experienced supply sergeants developed skills at estimating, but it was always estimation, never precise calculation. The American system eliminated estimation entirely through standardization. The psychological impact on German officers went beyond mere efficiency comparisons. What they were witnessing represented a fundamentally different philosophy of organization. German military tradition valued expertise, experience, and improvisation. Skilled officers and experienced sergeants who could organize complex operations through judgment and adaptation were highly prized. The system worked well when these skilled individuals were available. American military organization valued systems, procedures, and documentation. Any trained soldier could perform complex logistics tasks by following established procedures documented in technical manuals. The system worked consistently regardless of individual skill levels, because success depended on following procedures rather than exercising judgment. This difference had profound implications. When skilled German logistics personnel were killed, wounded, or captured, their expertise was lost. New personnel had to develop skills through experience, which took time and created inefficiencies during the learning period. When American logistics personnel were lost, replacements followed the same documented procedures and achieved comparable results immediately. The system was resilient because knowledge was embedded in documentation rather than individuals. German officers working at American motor pools witnessed this principle in vehicle maintenance. American military vehicles required maintenance just like German vehicles, but maintenance approaches differed fundamentally. American mechanics worked from comprehensive technical manuals that provided step-by-step instructions for every repair task. Diagnostic procedures were standardized with decision trees that guided mechanics through problem identification. Parts were catalogued systematically with illustrations showing placement and function. Maintenance schedules were fixed requirements checked off on forms. Specialized tools were designed and issued for specific tasks. Every mechanic followed the same procedures regardless of experience level. A mechanic maintaining a GMC truck in Mississippi used exactly the same procedures, tools, and schedules as a mechanic maintaining an identical GMC truck in France. The technical manual was the same. The parts catalogue was the same. The tools were the same. The procedures were the same. Maintenance quality was consistent because it depended on following documented procedures rather than individual skill. German mechanics, by contrast, relied more heavily on experience and improvisation. Technical documentation existed but was less comprehensive than American equivalents. Diagnostic procedures were typically learned through apprenticeship where experienced mechanics taught younger ones. Parts catalogues were less detailed, sometimes requiring mechanics to identify components through familiarity rather than documentation. Maintenance schedules existed as guidelines but were often adjusted based on mechanic judgment about vehicle condition. Standard tools were used, but mechanics frequently needed to improvise solutions when specialized tools were unavailable. This approach produced excellent results. When experienced mechanics were available, parts could be obtained, and time was adequate. German mechanics were highly skilled, often more skilled individually than American mechanics. But under wartime conditions, with experienced personnel being killed or wounded, parts becoming scarce, and time pressure constant, the German approach created problems. Inexperienced mechanics without documentation struggled. Parts shortages forced improvised repairs that were less reliable. Rushed maintenance missed problems that systematic procedures would have caught. The cumulative effect on vehicle readiness was substantial. By late 1944, operational readiness of German military transport vehicles averaged below 50% in many units. Trucks sat broken waiting for parts or qualified mechanics. American forces maintained readiness above 75% and often above 80%. Better maintenance procedures, better parts availability through standardization, better documentation allowing less experienced mechanics to work effectively all contributed to higher readiness rates. The mathematics were brutal and inescapable. If two armies each fielded 1,000 trucks, but one maintained 50% readiness while the other maintained 80% readiness, the Second Army had 600 more operational vehicles. That 60% advantage in operational vehicles translated directly into 60% more logistics capacity. The army with higher readiness could move more supplies with the same number of trucks. Combined with efficiency advantages from mechanized cargo handling using forklifts and pallets, the cumulative advantage became overwhelming. American forces moved supplies 5 to 10 times faster, using fewer vehicles maintained at higher readiness levels. German forces simply could not compete. This philosophy pervaded American military logistics. The GMC 2.5-ton truck, nicknamed the Deuce and a Half, was manufactured by multiple companies from identical specifications. Any part from one truck fit any other truck. Field mechanics did not need to identify which manufacturer built a vehicle before ordering parts. German military vehicles, by contrast, came from dozens of manufacturers with non-standardized components. Mercedes trucks required Mercedes parts. Opel required Opel parts. Field depots needed massive inventories to service all variants. American depots needed smaller inventories because standardization meant higher commonality. Standardization extended to human elements. American truck drivers received identical training regardless of location. Drivers' manuals were uniform across all commands. Maintenance procedures were documented in technical manuals distributed to every unit. A driver transferred between divisions could immediately operate in new units without retraining. German military training was more traditional. Experienced personnel taught new recruits, techniques, varied by unit. Knowledge was oral rather than written. This worked adequately in peacetime. It failed catastrophically under wartime attrition. When experienced German logistics personnel were killed, wounded, or captured, their knowledge died with them. American logistics were resilient because knowledge was embedded in systems rather than individuals. Spring 1945 brought Germany's collapse. News reached prison camps through official announcements and Red Cross reports. German officers listened to accounts of cities destroyed, armies surrendering, the Reich contracting daily. Many felt no surprise. They had seen the reason Germany lost. It was not heroism or tactics or strategy. It was forklifts and pallets and standardized systems that let America move supplies 10 times faster using fractions of the labor. Final statistics supported this conclusion with mathematical precision. The United States produced 300,000 aircraft during World War II. Germany produced 119,000. The United States built 88,000 tanks. Germany built 50,000. These production numbers mattered, but logistics mattered more. Weapons produced in factories had no value unless they reached soldiers. Ammunition stockpiled in depots did no damage unless delivered to front lines. Food in warehouses did not feed armies. The ability to move material efficiently determined how production translated into combat power. Consider the Battle of the Bulge in December 1944. German forces achieved complete tactical surprise, broke through American lines, and advanced rapidly. Initial success created optimism among German commanders. Then logistics reality intervened. German panzer divisions designed for rapid mobile warfare found themselves waiting for horse-drawn supply columns that struggled through winter weather on damaged roads. Fuel shortages halted tanks within sight of objectives. Ammunition shortages forced artillery to ration shells. The offensive ground to a halt not because American resistance was insurmountable, but because German supply systems could not sustain operations. American forces, by contrast, reorganized their supply networks within 48 hours of the German attack. The Red Ball Express, which had officially ended operations in November after the opening of Antwerp port, was partially reactivated. Additional truck routes were established, supply priorities were shifted. Within 72 hours, American depots were flowing ammunition, fuel, and supplies to defensive positions. When American forces counterattacked in early January 1945, they advanced behind a logistics system that sustained offensive operations for months. German forces retreated because they could not match either the firepower or the supply capacity of their opponents. This pattern had repeated throughout the war. In North Africa, German forces achieved tactical brilliance but ultimately failed because logistics could not sustain operations across Mediterranean supply lines, vulnerable to Allied interdiction. In Russia, German forces advanced rapidly in 1941, but collapsed when supply wagons could not keep pace with mechanized spearheads across vast distances. In Italy, German defenders fought skillfully but gradually retreated as Allied logistics provided continuous support for grinding advances. In France, after D-Day, German forces might win individual engagements but could not prevent Allied advances sustained by a logistics system delivering 12,500 tons of supplies daily at the peak of Red Ball Express operations. During the Normandy campaign from June through August 1944, Allied forces unloaded approximately 2 million tons of supplies across beaches and through captured ports. This included 500,000 tons of ammunition, 350,000 vehicles, and enough fuel to operate mechanized armies across France. German forces in the same theatre received less than 600,000 tons of supplies during the same period, despite operating much closer to their supply sources. The difference was not production capacity. German industry, despite Allied bombing, still produced substantial material. The difference was logistics capacity. Germany could not move supplies from factories to front lines efficiently enough to sustain operations. American logistics efficiency derived from multiple factors working in combination. Mechanized cargo handling using forklifts and pallets was one factor. Standardization of containers, vehicles, and procedures was another. Comprehensive planning and documentation was a third. Reliable maintenance that kept vehicles operational was a fourth. Redundant capacity that allowed for losses and breakdowns was a fifth. No single factor dominated. The cumulative effect of all factors working together created a system with resilience and capability that German logistics could not match. German officers who witnessed American operations for months understood this integration deeply. Many recorded detailed analysis in letters and journals written after Germany's surrender in May 1945. Their writings reveal systematic thinking about why Germany lost the logistics war. One common theme emerges across these accounts. American soldiers were brave, but so were German soldiers. American tanks were adequate, but German tanks like the Panther and Tiger were arguably superior in direct combat. American generals were competent, but German generals like Rommel and Manstein demonstrated tactical brilliance. Yet none of these factors determined the war's outcome. The decisive difference was logistics. Americans could sustain operations indefinitely because their supply system worked efficiently under all conditions. Germans could not sustain operations because their supply system failed repeatedly under stress. The implications were stark. A brave soldier without ammunition cannot fight effectively regardless of courage. A superior tank without fuel cannot move regardless of engineering quality. A brilliant general without supplies cannot execute strategies regardless of tactical skill. America understood this fundamental truth. Germany learned it too late to matter. This realization was widespread among German officers who had witnessed American logistics firsthand during their captivity. Their post-war writings, published in German military journals and memoirs over subsequent decades, describe similar reactions. Initial impressions upon seeing American supply depots were often that Americans were wasteful. So many machines to do work that men could do manually. So much equipment devoted to moving boxes instead of fighting. Then came the calculations that changed perspectives. The machines moved supplies 10 times faster than men working manually. The equipment freed combat soldiers from logistics duties, allowing armies to maintain higher ratios of fighting troops to support troops. What appeared wasteful was actually efficient. What seemed excessive was actually necessary. Modern industrial war required industrial logistics. Germany had tried to fight an industrial war using pre-industrial logistics methods and could not overcome that fundamental mismatch. German supply officers who worked at American quartermaster depots recorded particularly detailed observations about systematic organization. Every pallet had an identifying number stenciled on its side. Every number corresponded to a card in a filing system showing contents, origin, destination, and priority code. When units submitted supply requests, clerks consulted the filing system to identify required items. Workers noted pallet numbers on picking lists. Forklift operators retrieved specified pallets from storage. The picked items were assembled at loading docks according to priority codes. Higher priority, shipments loaded first. Documentation listing contents accompanied each shipment. Receiving units signed forms confirming delivery. Copies returned to the depot where clerks updated inventory records. The entire process was documented and procedural. Nothing was improvised. Every step followed established protocols. This systematic approach meant that relatively inexperienced personnel could perform complex logistics tasks successfully by following documented procedures. In German systems, experienced supply sergeants who had developed skills through years of service knew how to organize complex operations efficiently through judgment and adaptation. When those sergeants were killed in action, their expertise was lost and had to be rebuilt through new personnel gaining experience over time. American systems did not depend on accumulated individual expertise. They worked because procedures were thoroughly documented and consistently followed. Another German officer described watching the American approach to problem-solving in logistics operations. When issues arose such as damaged pallets, vehicle breakdowns, or shipping errors, Americans consulted technical manuals and procedural guides. Solutions were found in documentation. Supervisors did not need extensive experience because the documentation provided answers. This meant young sergeants with minimal experience could manage complex depot operations effectively. German military tradition valued experienced officers and sergeants who could handle unexpected situations through skill and improvisation. This approach worked excellently when those experienced personnel were available. But World War II imposed catastrophic attrition on German forces. Experienced logistics personnel were killed, wounded, or captured at high rates. Replacements were young and inexperienced. Without comprehensive documentation to guide them, these inexperienced personnel struggled to maintain efficiency. American systems were resilient against personnel losses because documentation preserved organizational knowledge independently of individuals. The disparity was not explained by production differences alone. German industry, despite sustained Allied bombing campaigns, continued producing substantial quantities of military equipment, ammunition, and supplies through 1944. The critical bottleneck was not production but distribution. Germany could not move supplies from factories to front lines efficiently enough to sustain combat operations at the intensity required. Supply trains were destroyed by air attacks. Trucks broke down from poor maintenance and parts shortages. Horse-drawn wagons could not keep pace with mechanized forces. Manual loading and unloading at depots created delays that compounded through the distribution system. American logistics suffered none of these crippling inefficiencies. Air superiority protected supply routes. High vehicle readiness rates maintained transport capacity. Mechanized cargo handling eliminated loading delays. Standardization ensured parts availability. Comprehensive documentation enabled even inexperienced personnel to maintain system performance. The cumulative effect was a logistics system that reliably converted industrial production into frontline combat power. German officers analyzing these differences identified specific capability gaps. One major gap was horse reliance. The German army that invaded France in 1940 contained 135 divisions. Only 16 were fully mechanized. The remaining 119 divisions relied heavily on horses for transportation. German forces invaded France, accompanied by approximately 750,000 horses pulling supply wagons and artillery. The vaunted Blitzkrieg was mechanized at the armored spear point, but supplied by methods essentially unchanged since Napoleonic times. The American army was approximately 85% mechanized by 1944. Even service units that did not require full motorization received priority for material handling equipment like forklifts. Supply points for American divisions typically had 4 to 8 forklifts, each for handling cargo. German divisions had 0 forklifts in their organic equipment. This fundamental difference in mechanization philosophy shaped everything else about how the two militaries operated logistically. German forces could achieve rapid advances when fuel and ammunition were available, but sustaining those advances required supply wagons that moved at walking pace pulled by horses requiring fodder. American forces advanced at similar rates but were supplied by trucks moving at highway speeds requiring only fuel. When American spearheads outran their supply lines, as happened in August 1944 during the race across France, the solution was to reorganize truck routes like the Red Ball Express. When German spearheads outran their supply lines, as happened repeatedly in Russia and France, there was no quick solution because the underlying transportation system was fundamentally limited by horse capabilities. Another capability gap was standardization. American military vehicles came from limited manufacturers building to common specifications. The GMC 2.5-ton truck, the primary American military cargo vehicle, was produced by General Motors, Studebaker, and REO Motor Car Company from identical designs. Parts were completely interchangeable. A transmission from a GMC-built truck fit perfectly in a Studebaker-built truck. Field mechanics did not need to know which company manufactured a specific vehicle before ordering spare parts. Any standard part fit any truck. German military trucks came from dozens of manufacturers, including Mercedes-Benz, Opel, MAN, Magirus, Bissing-Nag, and many others, each building to their own specifications. Mercedes trucks required Mercedes-specific parts. Opel trucks required Opel-specific parts. Field maintenance units needed vast inventories to service all vehicle types. When specific parts were unavailable, mechanics had to improvise repairs that were less reliable than proper fixes. The lack of standardization multiplied supply chain complexity and created persistent maintenance challenges. After repatriation to Germany in 1945 and 1946, these officers returned to a nation destroyed physically and economically. Most initially focused on immediate survival needs, locating surviving family members, finding shelter in bombed cities, securing food amid widespread shortages. But as Germany began rebuilding under Allied occupation, former German officers found themselves in positions to apply lessons learned during captivity. Many became industrial consultants, helping rebuild German manufacturing and distribution systems. They advocated for mechanization of materials handling, standardization of packaging and containers, systematic documentation of procedures, and comprehensive training programs. Their presentations to German business leaders often included comparisons between American and German logistics approaches. They showed how American systems achieved superior efficiency through mechanization and standardization, rather than relying on skilled individuals performing manual work. The message resonated in a Germany that needed to rebuild quickly with limited resources. Adopting American logistics principles allowed German industry to achieve more with less. The forklift became ubiquitous in German warehouses and factories during the 1950s. Pallet standardization spread rapidly through manufacturing and distribution sectors. Procedural documentation improved dramatically as companies recognized the value of embedding knowledge in systems rather than depending on key individuals. These changes contributed to West Germany's economic miracle that transformed the nation from Kochtrove, wartime devastation, to prosperity within 15 years. German military logistics were similarly transformed. When the Bundeswehr was established in 1955 as West Germany's new military force, it was designed from the beginning as a fully mechanized organization with logistics systems incorporating lessons learned from observing American operations. Gone were horse-drawn supply wagons that had characterized German logistics through World War II. Gone was the reliance on experienced individuals improvising solutions. The new German military emphasized standardization of equipment, mechanization of transport and materials handling, comprehensive documentation of all procedures, and systematic training that allowed any qualified soldier to perform logistics tasks by following established protocols. Officers who had witnessed American logistics superiority during their captivity ensured that Germany would not repeat the mistakes that had contributed to defeat. They understood that modern military forces required modern logistics systems built on industrial principles rather than traditional military approaches. The transformation was comprehensive and lasting. By the 1990s, unified Germany operated military logistics systems that in many respects matched or exceeded American capabilities in efficiency and effectiveness. The lessons learned by German officers during World War II captivity extended beyond purely military applications. Business schools in Germany began teaching logistics as a core discipline worthy of serious academic study rather than a minor practical concern. Engineering programs incorporated materials handling and distribution system design into curricula. Management training emphasized systematic organization and procedural documentation. The idea that systems and processes matter more than individual heroic effort became embedded in German industrial culture. Universities established dedicated logistics, research programs. Students studied American warehouse design principles, inventory management systems, and materials handling technologies. German engineering firms began specializing in logistics equipment manufacturing, initially producing forklifts and pallets under American licenses, then developing their own designs incorporating improvements. By the 1970s, German logistics equipment manufacturers were competing successfully in global markets, their products embodying lessons learned from observing American systems 3 decades earlier. The transformation of German logistics thinking represented one of history's most successful examples of learning from defeat. German officers had entered World War II confident in their military superiority, convinced that German organizational skills and fighting spirit would overcome material disadvantages. They learned through harsh experience that modern industrial warfare rewarded systematic efficiency over individual heroism. Production capacity meant nothing without distribution capability. Weapons meant nothing without reliable logistics. Courage meant nothing without sustainable supply. These lessons were painful but thorough. By witnessing American logistics in operation during their captivity, German officers received an education that could not have been obtained through study or instruction. They saw with their own eyes how systematic organization multiplied human capability. They experienced firsthand how standardization enabled optimization impossible with custom approaches. They watched documentation preserve knowledge and enable consistent performance regardless of personnel changes. They learned that mechanization was not laziness but intelligence, not luxury but necessity. When these officers returned to Germany and found themselves in positions to influence reconstruction, they applied these lessons comprehensively. The economic miracle that transformed West Germany from 1948 through the 1960s was built partly on knowledge gained in American prisoner camps. Former prisoners became industrial consultants, business executives, military planners, and government officials. They brought systematic thinking about logistics and organization to every role they filled. They evangelized American principles of mechanization, standardization, and documentation throughout German industry and government. The transformation was so successful that by the 1980s, German logistics and manufacturing systems were often cited as models of efficiency rivaling or exceeding American capabilities. The student had matched the teacher. The defeated had learned from the victor so thoroughly that they became competitive peers. This remarkable reversal demonstrated that defeat, properly analyzed and honestly confronted, could teach lessons as valuable as victory. German officers who witnessed American logistics superiority had the humility to recognize their errors, the intelligence to understand underlying principles, and the determination to apply lessons learned during their captivity. This transformation demonstrates that defeat, properly analyzed, can teach lessons as valuable as victory. German officers who witnessed American logistics in operation received an education in modern industrial organization that shaped their nation's reconstruction. They learned that efficiency comes from systems rather than individuals, that standardization enables optimization, that mechanization multiplies human capability, and that documentation preserves organizational knowledge. These lessons, applied systematically across German industry and military forces, contributed to Germany's successful transformation from defeated enemy to prosperous ally within 2 decades. The forklift represents this transformation symbolically. A simple machine that German pre-war planners had largely ignored became recognized as embodying principles essential for success in modern industrial operations. Mechanization of routine tasks frees human effort for higher-value activities. Standardization of materials and procedures enables systematic optimization. Documentation of processes allows knowledge to persist beyond individuals. These principles apply equally to military logistics, commercial distribution, manufacturing operations, and countless other domains. The adoption of these principles transformed not just German military logistics but German industry broadly. Companies that had relied on manual labor and skilled craftsmen for materials handling began investing in forklifts and mechanized systems. Manufacturers that had produced goods in custom configurations began standardizing dimensions and packaging. Organizations that had depended on experienced managers began documenting procedures systematically. The transformation took years, but fundamentally changed how German industry operated. German business leaders, who initially resisted these changes, often cited traditional values. German craftsmanship was superior. German workers took pride in manual skills. German products succeeded through quality, not standardization. But former prisoners who had witnessed American logistics in operation countered these arguments with evidence. American products were not inferior. American workers were not less skilled. American systems simply multiplied human capability through intelligent organization. Craftsmanship and systematization were not opposites. They were complementary approaches that together achieved superior results. By the 1960s, West German industry had largely completed the transformation. Forklifts were standard equipment in warehouses and factories. Pallets were standardized across industries. Procedures were documented in technical manuals. Training programs taught systematic approaches to logistics and operations management. The generation of German business leaders who came of age in the 1950s and 60s had been shaped by veterans who returned from American captivity with revolutionary ideas about organization and efficiency. The military transformation was equally comprehensive and in some ways more dramatic. The Wehrmacht that entered World War II with 750,000 horses was rebuilt as a completely mechanized force. The Bundeswehr, established in 1955, had 0 horses in its logistics system. Every supply function was mechanized. Every procedure was documented. Every system was designed for efficiency and standardization from the beginning. German military planners who had witnessed American logistics superiority were determined not to repeat past mistakes. The new German military procurement system emphasized standardization in ways the Wehrmacht never had. Vehicles came from limited manufacturers building to common specifications. Weapons systems used standardized ammunition types. Equipment employed Common interface standards. Training emphasized procedural adherence over individual improvisation. The entire organizational philosophy reflected lessons learned from American systems during World War II. Victory in industrial conflicts is determined not primarily by battlefield courage, tactical brilliance, or technological superiority in weapons, but by the ability to sustain operations through superior supply systems that reliably convert industrial production into frontline combat power. The Germans understood tactics and operational art at levels that arguably exceeded their opponents. The Americans understood logistics at levels the Germans had not achieved. Tactics won individual battles. Logistics won the war by enabling sustained operations that tactics alone could not maintain. The forklift and pallet revolution that transformed American military logistics during World War II created advantages that compounded throughout the conflict at every level. Faster cargo. Handling meant shorter ship turnaround times in ports. Shorter turnaround meant more efficient use of limited shipping capacity. More efficient shipping meant more supplies delivered to theaters. More supplies delivered meant greater operational capability for combat forces. Greater operational capability meant more successful campaigns. The cascade of efficiency extended through every level of the supply system, creating cumulative advantages that opponents could not overcome through superior tactics or weapons technology. The German military, still relying predominantly on manual labor for cargo handling and horse-drawn vehicles for transportation, could not compete against this systematic efficiency even when German forces achieved tactical victories. Every tactical success by German forces had to be supported by a logistics system that was fundamentally outmatched. The result was predictable. Germany could win battles but could not sustain campaigns because logistics failed, repeatedly under operational stress. The mechanization of material handling that forklifts and pallets enabled was not the only factor in Allied victory. Strategic decisions, industrial production capacity, technological developments, intelligence advantages, and many other factors all contributed significantly. But logistics mechanization was among the most important factors because it determined whether industrial production could be converted efficiently into combat power. Production without effective distribution creates stockpiles that do not affect battlefield outcomes. Weapons without reliable ammunition supply cannot be used effectively. Armies without dependable logistics cannot sustain operations regardless of tactical skill. The Americans grasped these truths early and built their entire military logistics system around them. The Germans learned them late, after the war was already lost. Superior logistics, enabled by mechanization and standardization, had proven more decisive than courage, tactics, or weapons technology. The forklift had become a weapon in the most fundamental sense, a tool that helped win the war by enabling all other operations. In the hands of American logistics personnel who understood systematic organization, this simple machine and the systems built around it helped achieve victory by ensuring that American military forces were consistently better supplied than their opponents in every theater throughout the war.